Today we're going to kick off with grade 10, and I'm going to do a little teacher slot on the real number system. But you guys have got to actually let Indiana know if what I've explained you're still battling with, and either email her or Facebook or Twitter any of your problems, and she'll just forward that on to me, and that's how we're going to form the show today at least. What I'm going to start off with is the real number system. Now, most of you in grade 9 have developed an understanding of 3 different number systems, and that's the naturals, the wholes, and the integers. So we're just going to quickly have a check that you know that the natural numbers is going to be, yes, we thought that something would go wrong initially. The natural numbers is the set of the numbers 1, 2, 3, etc. And then, of course, if we take it down to the whole number system, every single number in the natural number system is in the whole number system, okay? And so we actually take it as 0, 1, 2, 3. So some of you might be saying, does that mean that every natural number is whole? Well, yes, it does. But is every whole number natural? No, because 0 is a whole number, and the naturals do not include 0. Okay, then along came the next number system that you worked with in grade 8 initially, and if you remember, the integers started off and came through the negative wholes, and then it actually started incorporating all of the whole numbers as well. So can you see that the most basic set is the naturals? Then we just expanded a little bit into the wholes. Then we add all the negative numbers as well, and then that becomes our integer system. So if I ask you to list all the integers, you cannot. Just like you cannot list all the wholes, just like you cannot list all the naturals, because they go on forever and ever and ever in a day. Okay, so that is what you should have been very comfortable with at the end of last year. Now what you might be saying to yourself is, what about numbers like a half, or numbers like 2/5, or something like 13/7? Can you see that those are numbers very definitely in our number world? We deal with them every day. So do they fit into our naturals? No. Do they fit into our wholes? Definitely not. And they definitely don't fit into our integer number system. So we need to find a new way of describing this kind of number. And so we come up with a name called the rational numbers. All right? Now, I want you to think about that word rational. And look at this word fraction. All right, can you see that if I underline RAT and TIO, can you see there that we've got the same names there, ratio and RATIO. So rational numbers is actually the set of anything that can be written as a fraction. So by definition, if a number can be written as A over B, then we know that it is rational. All right? But let's just be very specific here. Do you agree that B cannot be 0? And I think that you would have learned last year that anything divided by 0, okay, actually is undefined. So the only thing that we are actually preventing you from having B take the value of is a 0. Okay, right, so let's have a look at something. Let's say I take 0,1. Is that actually a rational number? Well, let's think about 0,1. I think you would all agree that 0,1, which is a decimal number, can be changed to 1 over 10. So therefore it's a fraction, and so therefore it is very definitely rational. Okay? What if I take it now and expand that to 0,12? So all I'm doing is I'm taking it and I'm making it 2 decimal places instead of 1 decimal place. So can you remember from last year that 0,12 is actually the same as 12 divided by 100? Now 12 divided by 100 is a fraction, and it could also be written as 6 over 50, and it could also be written as 3 over 25. So can you see that this thing, which was a decimal, is definitely writable as a fraction, so it is rational. All right, let's take one more example, and let's take 0,125. Now, can you see all I'm doing is adding an extra decimal place? And so what we're going to be getting is 125, and I'm hoping that you're all understanding that because I've now got tens, hundreds, thousandths, I'm now going to 125 over 1,000, and if I simplify that down, it's 125 divides into 1,000 8 times, and so you can see that that is also rational. So, are you with me? We now have anything that can be written as a fraction, all right? Even a decimal number is now rational. So your next question might be, what about this decimal number? Okay, Indiana, think of a number. What number? Scream it out to me.
Any number.
Any number.
8.
And then another one.
10.
Okay, and then 2 more.
15.
And then another one.
3.
Okay.
So too
now
easy.
This number, very easy. Okay, this number you can see, I'm just going on forever at random. And can you see that this dot, 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 dot is just indicating that it's going to go on forever and ever and ever. And there's no predicted pattern, okay? So all that I can say is this going to be writable as a fraction? So that's going to be my question, is can this decimal, okay, because I've showed you that these decimals up here can be written as a fraction, so they're rationals, but can this one be written as a fraction? And so that's actually what we have to discuss. Okay, so let's get a new pane and see where we're going with this. All right, have you seen this at school? 0,1 with a big fat dot on the top. I'm hoping that you have and that you know that that 0,1, that dot means that the 1 must recur. All right, and so that is actually what this thing means. Now, if I were to suggest that the next number was a 1, and the next one, and the next one, and the next one, can you see that what has happened is that it's established a pattern? I expect the next number to be a 1. Unlike that one that I had before where I didn't have a clue what was coming next, this one I know for sure that the next number is going to be a 1. Now, I'm telling you that this we can write as a fraction. So I need to tell you how you're going to do this. And this is where the maths comes in. If you put this into your calculator, it'll actually give you the fraction. But we normally don't give marks for just putting things into the calculator. We always have to show our working to make this rational. Okay. So this is my technique. Somewhere along the line, algebra had to creep in. So what I do is I let x be this number 0,1111111, etc. Okay? Now, can you see that there's one decimal place recurring? So if I multiply x by 10, then I'm going to get 10x. But if I multiply the left-hand side by 10, then what I'm going to have to do is multiply the right-hand side by 10 as well. Okay, that's my kind of balance of equations. So if I multiply this by 10, I hope that you remember that that means that the decimal place moves one place. So it's going to become 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, etc. Okay? So all I've done is I started with the original. I've multiplied the left-hand side by 10 and the right-hand side. So let's just say here what I've done. I've multiplied by 10. Okay? Now, can you see that if I'm very clever, I can engineer all of these decimal places which are bugging me, I can make them disappear. So let's look at what would happen if I take this bottom line and subtract the top line. So if I take the bottom and I minus the top, I'm going to get 10x take away x. That gives you 9x. And then if I take the bottom one, take away the top one, can you see that all of these decimal places are going to disappear and I'm going to get a 1. Right. Now, I've got 9x equals 1. And so you know that that means that if we divide both sides by 9, all right, I'm going to get x is equal to 1 over 9. So ladies and gentlemen, it means that 0, 1 recurring, if we write that as a fraction, it's 1/9. Now I guarantee you, if you put 1/9 into your calculator, it comes out on the other side as 0, 1, 1, 1, 1, etc.
Okay, so Heather, are you ready for this?
I'm ready.
Okay, can you say that rational numbers is when the number is a negative or a positive whole number, or if the decimal is recurring decimals or terminating decimals?
Okay, Indiana and Pumalelo
Yes.
is absolutely spot on. So the question is, if you were asked what is a rational number, can you say it is negative and positive whole numbers? Yes, so that's our integers. And then is it the terminating and repeating decimals? Absolutely, because we've shown that when the decimal terminates, we can write as a fraction, and when the decimal sets up some kind of a pattern, we can write it as a fraction. Okay, so yes, absolutely wonderful question. Mpumelelo, the best thing about understanding maths is kind of putting it into your own words, and you've done that beautifully, so well done. Okay, I think she needs the calculator.
Yes, well, I think somebody should phone in, okay?
Okay.
You know, I think,
Okay, all right, I won't change things.
Yeah.
Okay, all right, so guys, I'm going back to this because this is the next piece of discussion around where rationals end and where the irrationals begin. So I'm sure that all of you are familiar with this notation. This is, we read it the square root of 4, the square root of 5, the square root of 6, the square root of 7, square root of 25. Now, if you have a look at the square root of 4, mentally, we know that the square root of 4 is 2. Okay? We get that because we know that 4 is 2 times 2, or 2 squared. Now, if we go to square root of 5, I'm sure you understand that the square root of 5 we cannot do just in our head. The square root of 6, the square root of 7 likewise. But if I were to give you the square root of 25, you would all be jumping up and down and saying that that answer is 5. So these ones here, all right, if we wanted to work them out, we would actually need, okay, the calculator. All right?
Heather, before you go on, I just want to
Yeah.
say, well done to Kutso, because he kind of went, he said 5, the answer's 5, so well done, Kutso.
Perfect, wonderful. Okay, so we're going to need the calculator. But before we go to the calculator, your teachers are going to expect you to guess how big that square root of 5 is. Now, if we go to a number line, okay, let's just bring back. If we go to a number line and we take the root of 5, what we need to understand, and this isn't really getting me to where I need it to be, so if we go the root of 5, okay, the gremlins are really here. All right?
It's okay.
I'm certain that all of you would know that on the number line, if we were to put the numbers 1, 2, 3, and 4, 1 is the same as the square root of 1. 2 is equivalent to the root of 4. 3 is equivalent to the root of 9. 4 is equivalent to the root of 16. So if we wanted to work out the root of 5, can you see that it would have to fit somewhere in there between the root of 4 and the root of 9? So basically, I would know that the root of 5 has to lie between the root of 9 and the root of 4. What do we know about the root of 4? It's 2. Now the root of 5 is irrational, and the root of 9 is 3. So your teachers might ask you to say, tell me between which two consecutive integers the root of 5 lies. Now you know that it lies somewhere between 2 and 3. Now unfortunately, our calculator function is still being upgraded, but what I would really like you to do is to go and punch into your calculator the root of 5. And it'll come out as 2 comma, and I'm really not worried about all of this, but on the screen there will be a whole lot of decimals, okay, and they won't be repeating. And even although what you see on your screen ends here, there are a whole lot of other numbers which your screen doesn't have the capacity to show us. So the root of 5 is actually a non-terminating, so it doesn't end, and a non-repeating decimal, which means therefore that it is an irrational number. Now, most of you have been introduced to pi down in the primary school, and you have been told that pi is 22 over 7.
So it's not gravy pie? Yeah?
No, not gravy pie, not apple pie, but pie. Okay. Now, if you were told that in the prep or the primary school, you have been lied to. So unfortunately, I'm very sorry, but teachers do lie. Because if they told you that pi was 22 over 7, they've lied. Okay, let me explain a little bit and then you'll understand why I say this. Okay, pi is actually 3,14, and then it keeps on going, all right? And I'm not exaggerating when I tell you that if you were to write out all the decimal places of pi, it would actually stretch about 4 kilometers in distance, okay? So it keeps on going, and there's no pattern, and there is absolutely no termination. So pi is actually what we call an irrational number, because it doesn't repeat and it doesn't end, okay? But can you imagine if in prep they had made you to work with all these decimal places? So what they decided to do is they actually took pi and they estimated it, and they said that it's, if we round it off, it's about 3,14. So what they did is that they chopped it off and they just made us use 3,14. Or what they did is they said that pi, we could also use it as 3 1/7, because that is an approximation, and you can see that 3 1/7 is 22 over 7. So in the preps, they told you to use this, but in fact, they are not equal. Pi is 3,14 with all of these decimal places. it's only approximately, if we work it to 2 decimal places, it's 3,14. And if we take it to a rational approximation, all right, it's 22/7. But pi is not 22/7. Okay, that's the closest fraction number that pi can get to. But in fact, pi has got all of these decimals. Okay. Right, let's see if we can just do one last question for that caller who, or not, it was on Facebook, if we've got the time. The candidate wanted us to prove that this is rational. Okay, so we've done one like this before. The only thing is that we're just going to have to take care of that 8 there, which was not there in my previous example. All right, so guys, we're going to follow the kind of steps. We're going to let our x number be 8, 36, 36, 36, 36, and we don't have to put in many more than that. Right, then we're going to multiply by 10 both sides, and if we multiply by 10, can you see that it's going to become 83, 63, 63, 63, ... Now remember what I said? It's got 2 dots repeating, so multiplying by 10 isn't going to be good enough. We're going to have to multiply by 100. And so if we multiply by 100, we're going to have to bring one more number to the front. So it's going to become 836, 36, 36, 36, etc. Now can you see that if you choose that one and that one, what you're going to do is you're going to take 836, 36, 36, 36, and you're going to subtract the top level, and all of these 36s are going to knock each other off. So on the left-hand side, you're going to get 99x, and on the right-hand side, you are going to get 836, 3636, take away 8, 3636, and that's going to give you 828, nothing. And that's your target, is you don't want any comma things at the end here. You want to get rid of all those decimals. And so your final answer is going to be quite simply x is equal to 828 over 99. Now you wouldn't dare leave it like that in my class. If you were in my class, you would then have to change it into a mixed fraction.
We are here to answer any questions that you may have, and always remember, guys, facebook.com/learnextra. We are a 48-hour help desk. As long as you type the questions and let us know exactly where you're stuck and what you need help with, then we can get back to you and help you out.